Welcome to video 4 of 5 in our Learning Bites series, sponsored by the Alberta Real Estate Foundation and developed and presented by SAIT's Green Building Technologies Research Group. My name is Ben, and I'll be your guide through this video of the series. This video will lead you through various sustainability features in relation to green and healthy homes, building on what you just learned about high-performance homes. We're going to look at a few more elements that would take a home from high performance to the next level of green, such as LEED Platinum. We'll cover the following topics. What's in a name? Defining green and healthy homes, green rating systems, outlining common green building rating systems such as LEED and Passive House. Case studies, we'll be reviewing a few green home examples. Sustainable features, reviewing popular sustainability features that one might find in a green home. And finally, what you won't find in the green home, explaining materials that are hazardous to occupants. At the end of this video, you'll be able to identify special sustainability features in an existing home, and you'll also be able to offer suggestions for incorporating sustainability features into a new or existing home. Because infrastructure can last for several decades, new construction and renovations are a significant investment that need to be properly planned with a long-term vision of how it will benefit and not burden future generations. Here are some of the terms we'll be discussing in this video: biophilic design, toxic chemicals, geothermal systems, acoustics, dark sky lighting, and more. Are you ready? Okay, let's get rolling. What do we call a building that has sustainability features? Today, several different terms or names are used to define these buildings. Depending on what features they contain, and these are somewhat interchangeable, homes may be called green, sustainable, healthy, eco, environmentally friendly, or even regenerative. The three most common terms we use for these homes are green, sustainable, or healthy, all of which refer to living in a healthy environment in harmony with the natural environment, both in a building's interior and exterior. These overlapping terms could refer to using products and practices that are good for people and the environment, employing natural materials, utilizing renewable resources, avoiding unhealthy emissions, and minimizing waste, among others. The term green tends to focus on the present or the near-term future, specifically the time frame of one's own lifetime. Sustainability tends to address resiliency and longevity with the goal of a greener tomorrow. And healthy tends to focus on the health of occupants and the health of the natural environment. Some people even call homes by their third-party certification, such as a LEED home, a Passive House, or a Living Building Challenge home. Their names originate from their intent, or sometimes it's just a matter of personal preference. For example, if a home is aiming to achieve net zero energy performance, it may be called a net zero home or a high efficiency home. That might all sound complicated, but all being said, a green home is a sort of an umbrella term, you could say. To simplify things, we'll use it throughout these videos as a catch-all phrase. So when and where did the idea of a green building start? Well, technically speaking, many civilizations have been building sustainably for thousands of years. But in the more practical sense, green buildings as we know them today have existed since the 1970s. There are far too many details to mention, so we'll just look at a few highlights. Where did it all start? Well, during the 1960s, when the world was witnessing great advancements in architecture through the innovation of skyscrapers, glass buildings, and homes of the future, concerns were rising about the future cost of living. At the same time, the environmental movement was growing, as evident in Rachel Carson's best-selling Silent Spring book. Earth Day was also launched, and the government legislated environmental policies. As oil prices were spiking in the USA, scientists, architects, and engineers alike began to realize the necessity for renewable energies and improving building efficiency and performance. With global populations growing exponentially, it was recognized that the Earth's resources are finite and that perhaps we could do things differently. Much progress was made over the decades, but it wasn't until the 1990s when formalized green building programs began to appear, starting with Energy Star, which you learned all about in video 3. Also in the 1990s, there was a noticeable rapid uptake in green building initiatives, such as the founding of many green building certification systems. First came BREEAM in the UK, then LEED in the USA, and currently over 100 rating systems and programs exist all around the world. Next, we'll go over some of the more common certification systems used today. LEED, which stands for Leadership in Energy and Environmental Design, version 4.1, is a prescriptive system for designing, constructing, and certifying green buildings. Founded in 1993 and adopted by the Canadian Green Building Council, or CAGBC, in 2003, LEED is arguably the most popular green building certification program in North America. Buildings are awarded under the LEED residential stream as certified, silver, gold, or platinum, depending upon the number of points they acquire within these 9 categories: integrative process, location and transportation, sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, innovation, and regional priority. Within each category, there are various credits available that result in points. More points achieved in a greener building and a higher LEED rating level. Originating in Germany, Passive House is a voluntary standard for energy efficiency in buildings. The first Passive House project in Darmstadt-Kranichstein, Germany, was Europe's first inhabited multifamily residence to achieve an annual energy consumption below 10 kilowatt hours per square meter. The Passive House rating system came to Western Canada in 2013, but expanded across the country with increased demand, and Passive House Canada was officially founded in 2016. The Passive House philosophy centers around buildings that are constructed to have very low energy demands. Key features of the certification are the stringent airtightness and energy use requirements. The Living Building Challenge, created by the International Living Future Institute, is a philosophy, advocacy, and certification program that is considered the most rigorous green building certification program in the world. This certification applies to commercial and residential builds, and the 7 areas of focus are place, water, energy, health and happiness, materials, equity, and beauty. Some components of the challenge are to use products with non-toxic ingredients to incorporate nature into the design of the home, to produce 105% of energy and water needs on site, and to achieve nearly 100% waste diversion over the duration of the project. The Canadian Home Builders Association first introduced the Net Zero Home Labeling Program in 2015, and since then has labeled over 600 homes. This is a residential program that focuses on increasing the home's energy performance to achieve net zero energy. A net zero home generates on-site energy equal to the total energy it consumes within a year. Energy is generated using solar, wind, or other renewable energy systems. More recently, the program has expanded to include the Net Zero Ready Home Labeling Program, which can be awarded to homes that only require the addition of a renewable system. The goal of this program is to significantly minimize each household's environmental footprint by preserving our natural resources and protecting against climate change. An Inner Guide for Homes label is an official record of a home's energy performance. A home is rated based on its annual energy consumption in gigajoules. A rating of 0 would indicate net zero energy performance, the best score a home can get. The label makes a comparison against a benchmark home, shows where the energy is consumed, and demonstrates the environmental impact. Built Green by Built Green Canada is a residential green building certification program that includes single-family homes and multifamily units. Built Green accounts for materials, indoor air quality, ventilation, waste management, and water conservation. Built Green's single-family program was created in 2003 and is a certification that includes the Inner Guide label by Natural Resources Canada and the Built Green seal. The Building Research Establishment's environmental assessment method is the world's first sustainability rating system, established in 1990 in England and inspiring the creation of LEED 8 years later. BREEAM is different from other certification programs by requiring trained personnel to report certifications to the research organization. BREEAM categories include energy, health and well-being, innovation, land use, materials, management, pollution, transport, waste, and water. Now that we've reviewed some of the green building rating systems that are prevalent in the world, let's take a look at some of the applications of these systems in homes that have been constructed. In 1977, the Saskatchewan Conservation House was built to demonstrate the effectiveness of increased insulation, airtightness, and triple-pane windows. The home's design began with an improved envelope, which included additional insulation and airtight walls to help keep the interior temperature consistent. This, in turn, reduced the loads on the heating and cooling equipment. This home was designed and oriented to maximize solar heat gain, to passively heat the home while utilizing shade from awnings and roof overhangs during peak solar hours to prevent overheating. A heat recovery ventilator was installed to supply the home with fresh air, making it one of the first residential applications for this type of space heating. At its prime, this home was estimated to have consumed 85% less energy than typical homes in the 1970s. Across the pond in Germany, the world's first official passive house would be built in 1990. This row of 4 houses with 3 stories built in Darmstadt used similar design methods to the Saskatchewan Conservation House, such as increased insulation, a sloped roof, and optimal orientation to capitalize on passive solar gains. This building goes a step further in its HVAC design. Fresh air is supplied to living and sleeping rooms of the units, and stale air is collected from the more humid rooms, such as the kitchen and bathrooms, and exhausted out of the home. This home also utilizes a geothermal system below the building, which utilizes the natural heat of the ground. The system accesses heat at a constant temperature below the freezing level to warm the fresh supply air. In 2015, the Edelweiss House in Wakefield, Quebec, was the first home in Canada to achieve LEED Platinum, the highest level of LEED certification possible. Passive heating through the windows, as well as an air source heat pump and hydronic in-floor radiant heating, allow the home to operate at little to no cost to the homeowners. Furthermore, the home's water system boasts an average of 60% savings compared to typical homes of the same size. Along with features such as a green roof and radon barrier, these energy, water, and heating improvements are all key approaches in the LEED rating system. From the perspective of a homeowner, selecting a home and its features comes down to personal preference. It could be the biggest investment someone will make in a lifetime. So are homeowners interested in green homes and sustainability features? The answer is yes, in varying degrees. And we'll discuss this in much more depth in video 5. In addition to some of the features we have mentioned in video 3, there are many sustainability features that can be incorporated into a new or existing home. Let's take a look at a few in the areas of water, design, natural elements, comfort, materials, indoor air quality, and technology. Integrating sustainability features works best when ideas are being conceptualized. Some sustainability features are most effective when incorporated at the design phase, but sometimes they can also be considered during a renovation. Thermal mass is the ability of a material to store and release heat. Some materials are able to absorb and store more heat than others and release it slower, such as a strategically placed stone hearth around a hot fireplace. These materials are referred to as thermal mass and are often heavy construction materials such as concrete and stone. Typically, materials that are dense and darker in color will absorb and store heat better. Thermal mass is an important design consideration in high-efficiency homes due to their ability to help stabilize changing temperatures. In recent years, there is an increased focus towards the carbon footprint of buildings. This doesn't only include carbon emissions, but also the embodied carbon of materials. Embodied carbon measures the amount of greenhouse gases a material may generate over the course of its lifetime. Embodied carbon also speaks to a material's ability to sequester and hold carbon, delaying its release into the atmosphere. Wood and natural fibrous materials are excellent for carbon sequestration, given that they intrinsically remove and store carbon just by existing. On the other hand, materials like steel and concrete sequester no carbon and have extremely high carbon footprints due to their extraction and manufacturing processes. Considering the embodied carbon of specific products is best completed in the design phase. Closely correlated is a life cycle assessment, which is the process and documentation of a material's compact carbon impact through all stages of its life. This includes pre-manufacturing, such as the harvesting of trees, manufacturing, transportation and delivery, construction and assembly, operational lifespan, demolition, reusability, and finally, decomposition. LCAs are published and are available publicly, which makes it relatively simple to select products that have given intentional consideration to its impact. Directional orientation of a building contributes to energy efficiency. In the Northern Hemisphere, strategic orientation will allow the building to passively absorb the heat from the sun and store this energy in the thermal mass of the building. While south-facing windows will capture light throughout the day, east-facing windows capture the morning light, and west-facing windows capture the afternoon light. Heat from the sun absorbed into the building is called radiant heat, which can reduce energy costs in the winter in Canada. However, in the summer, it can add to cooling costs if not done properly. During the winter, the sun is lower in the sky, and during the summer, the sun is higher in the sky. Therefore, exterior light shelves and window treatments should be considered to promote radiant heat in the winter and reduce radiant heat in the summer. The floor area ratio is a term used to determine the total floor area of the building compared to the size of the property that the building is on. This is a density ratio. A higher number indicates higher density, whereas a lower number indicates lower density. Density is a useful measurement within the green building industry because effectively using space can reduce the negative impacts of urban sprawl. It is calculated by dividing the gross floor area of a building, which is the combined floor area of every level, by the total buildable area of the property. Because it is a ratio, it has no measurement units. Windows in a home offer daylight and views, which are both critical to the health and well-being of the occupants, but they can offer far more benefits if they are operable rather than fixed. Operable windows can provide fresh air to the building, help regulate temperature, and provide a sensory connection to nature. Doors with glazing provide similar benefits, providing fresh air, daylight, views, and direct access to the outdoors. Every regularly occupied room should have an operable window as a manual option for regulating temperature and airflow. Comfort is an aspect of green homes that affects occupants' health and well-being. Let's have a look at these types of features. Daylighting is an important aspect of architecture and interior design. It is a connection to natural systems and can impact the physical and mental health of occupants. Natural light can control the body's circadian system, affect mood, reduce depression, improve sleep, lessen agitation, and ease pain. Natural lighting not only improves the health of occupants, but also creates an uplifting and bright environment with its heat and intensity. It's critical that daylight is incorporated into spaces of the home that are regularly used by occupants. Views are another design strategy to connect occupants to natural systems. A connection to nature within buildings can provide a greater eudaimonic well-being, a feeling that brings purpose into life. Window placement, glazing type, window elements such as a screen, and the surrounding environment are factors of the efficacy of views. Preference is given to windows with multiple sightlines that are not obstructed by filtered glazing or distorted colors. Other important factors are to select the correct size and quantity of windows for a room and to prioritize a direct line of sight through the window from multiple spots in a room. For example, LEED version 4 certification requires that 75% of the occupied space must have a direct line of sight to the outdoors, while BREEAM requires 95% of the floor area in each room to be within 7 meters of a wall with an opening. Thermal comfort is an important consideration to the overall comfort of a building. ASHRAE Standard 55 cites 6 factors that affect thermal comfort of occupants: metabolic rate, clothing insulation, air temperature, radiant temperature, airspeed, and humidity. Metabolic rate and clothing insulation are personal attributes. However, the other 4 are factors of the thermal environment that can be supplemented with manual options to provide a comfortable temperature. For example, adjustable thermostats, ceiling fans, operable windows, and window shades are controlling factors, and these manual options should be available to occupants for different spaces within a home. Acoustics is an invisible element that is often overlooked during the design process, but a green and healthy home should demonstrate superior sound attenuation. Sound affects all of our day-to-day activities, and unwanted noise leads to sleep disturbance, prolonged healing, reduced speech perception, and vocal fatigue. There are acoustical elements to improve building occupant health, safety, functionality, and comfort regarding background noise, sound transmission, reverberation time, and site exterior noise. One can reduce environmental noise intrusion and distraction from outside noise using strategies such as achieving a balance between absorptive and reflective surfaces and materials into a space. As we all know, water is essential to life on Earth, and because of that, it must be managed in a way that is not wasteful. Water is a finite resource. Even though about 70% of the Earth's surface is covered by water, less than 1% is available for human use. Homes play a significant role in how much water is consumed, and there are plenty of options when it comes to reducing usage. In Calgary, the average person uses about 7,000 liters of water per month. This graphic shows how water is used within a typical Calgary home, assuming the use of low-flow toilets and fixtures. The water use per line item ranges from about 30 liters to 950 liters. First and foremost, there are simple water conservation behavior changes that should be considered, such as taking shorter showers, filling the bath half full when bathing children, turning off the faucet while brushing teeth, shaving, or washing dishes, regularly inspecting and repairing water leaks in toilets or other fixtures, and allowing the yellow to mellow. But let's turn our attention to physical changes that can be made. Older toilets can use as much as 23 liters of water for every single flush. Over the years, toilet flush technology has improved, and low-flow toilets now use less than 4.8 liters per flush. A family of 4 could save over 111,000 liters of water annually by switching to a low-flow toilet. Dual-flush toilets perform slightly better with a light flush of less than 4.1 liters and a heavy flush of less than 6 liters. WaterSense certified toilets are the most efficient, using less than 4 liters per flush. You can find these numbers on any toilet, typically marked with an LPF number. Low-flow faucets and shower heads have also improved over the years, allowing for the same perceived water pressure while using less water overall. Another option is to install an aerator to help reduce the amount of water flowing from an older faucet. Dishwashers, clothes washing machines, water heaters, and fridges are some of the household appliances that require water to operate, and newer models are typically more water efficient. These appliances are available with an Energy Star label found right on the appliance, as discussed in video 3. While Energy Star appliances use less electricity than their non-labeled counterparts, the Energy Star website highlights that these types of appliances also use less water. For new builds, or when it comes to replace appliances, Energy Star models should be selected, and there are usually rebates available for doing so. A WaterSense label, although not yet available in Canada, is another third-party label that designates products that are certified to use at least 20% less water, save energy, and perform as well or better than regular models. This American-based label is a voluntary partnership program sponsored by the U.S. Environmental Protection Agency that identifies water-efficient products and acts as a resource for consumers. Did you notice in the earlier water use graphic that lawn watering uses upwards of 950 liters per hour? One way to dramatically reduce this number is to transition your yard to xeriscaping. Xeri is the Greek root word for dry. Therefore, xeriscaping is a landscaping method developed especially for arid and semi-arid climates that utilizes water-conserving techniques such as the use of drought-tolerant plants, mulch, and efficient irrigation. This strategy won't work in all climates, but it can work in varying degrees in every climate. Installing a high-efficiency irrigation system, which uses drip emitters and weather-sensing technology, is significantly more water efficient when compared to traditional lawn sprinklers. These systems utilize a timer or controller to activate the valves for each watering zone at the best time of day to minimize evaporative losses while obeying local regulations and water use guidance. Moisture sensor and rate delay controllers make this an easy option for homeowners. Rainwater harvesting is the practice of collecting and storing rainwater or snow melt for future use. This stored water can be used for outdoor irrigation, domestic purposes like flushing toilets or washing clothes, and sometimes even potable uses depending on the jurisdiction. By harvesting precipitation, the demand on municipal water is reduced. Less water enters the stormwater system, and groundwater can be replenished. Rain barrels can be purchased at a hardware store and easily installed by a homeowner. It's a simple action that, multiplied by many homeowners, can make a positive impact on preserving our water sources. Bringing nature into your home is another aspect of green homes. Let's look at some examples. The use of natural products in a building provides many mental and physical benefits. Natural materials can include wood, stone, clay, metal, and glass, just to name a few. These materials are beneficial because they typically do not contain toxic chemicals that could negatively affect indoor air quality. They can provide a mental benefit for occupants due to their color, texture, sight, and smell, which connect occupants to nature. Incorporating natural elements is called biophilic design. These materials will age over time, changing shape and form as done in nature. An example of this is a wood feature aging and darkening, resulting in rich tones and natural discolorations. Contrarily, synthetic materials such as PVC, vinyl, and carpet do not have the same mental benefits, can be less durable, and can contain toxic chemicals. Biophilia comes from the root words bio, which is living, and philia, which is a prefix for love. Together, biophilia means the love of the living. The biophilic hypothesis suggests that humans have an innate affiliation to nature and other forms of life, meaning that as humans we want to be connected to nature. Biophilic design is a design strategy used to connect occupants with nature directly and indirectly, and studies have proven this to have a positive impact on mental and physical health. Incorporating biophilic elements such as natural materials and emulating the surrounding environment's textures and tones into the design helps promote and enhance human-nature relationships within buildings. There are 72 attributes within the 6 principles of biophilic design: environmental features, natural shapes and forms, natural patterns and processes, light and space, place-based relationships, and evolved human-nature relationships. From a sustainability point of view, creating biophilic spaces offers comfort and well-being to occupants. Sometimes called a vegetated roof or an eco-roof, a green roof consists of vegetation over a waterproofing system that is installed over a flat or gently sloped roof. Not common to a typical house, a green roof can limit rainwater runoff, reduce energy use, provide homegrown food, and lessen the heat island effect. Additionally, green roofs are acoustically beneficial to buildings. They increase the mass of the roof, thereby improving sound isolation through the roof. They can cost more than a traditional roof, they may require extra structural support, and they will need maintenance. But in the correct setting, this green feature can be a great option for home buyers. Did you know that just like trees, plants can absorb significant amounts of carbon dioxide from a room? NASA even suggests that there are specific species that act as purifiers to filter harmful toxins and pollutants from the air. Plants can purify the air, produce oxygen, and improve mood, all while offering a direct connection with nature. It's like bringing the outdoors inside. The best part is that there are endless varieties to choose from, and they can be a great addition to any decor, from minimalism to rustic. Materials play a key role in both occupant health and the environmental aspects of green homes. Let's look into this. Choosing local materials encompasses all aspects of sustainability. economic, social, and environmental. Utilizing nearby materials supports the local economy, supports quality jobs in local communities, and reduces greenhouse gas emissions associated with transportation. Additionally, local home builders, contractors, and tradespeople should be prioritized for new developments to help reduce costs of travel and accommodation and to promote local businesses. It's hard to tell if an already installed product is sourced locally, but for new builds and renovations, it's relatively easy to source products that are manufactured locally. There are chemicals found in everyday building products that are extremely hazardous. They can be toxic, carcinogenic, mutagenic, and cause disruptions to hormones and reproductive tracts, or cause mental and physical growing defects. These chemicals are harmful for occupants, individuals in the supply chain, and the environment. By prioritizing non-toxic products, these dangerous chemicals are being removed from the supply chain, hence providing healthy interior spaces for the occupants and preventing the contamination of the natural environment via the processes of manufacturing, installation, and disposal. Some examples of toxic products commonly used in building materials include lead in door handles, lead in water pipes, PVC in wires, VOCs in sealants and flooring products, formaldehyde in composite wood products, and HFRs or halogenated flame retardants in most foam insulations. It can be difficult to recognize the toxicity of already installed building products, but for new builds and renovations, it's important to source non-toxic products as much as possible. Upfront investment in higher quality and more durable materials and components will ensure better long-term performance and reduce maintenance requirements. Following the design of a building, a phase known as value engineering is often completed to suggest cost-saving options. In many cases, this will include substituting a lower-cost material or product for what was originally specified in the building design. Usually, lower-cost materials and their components are less durable than their costlier alternatives. Materials and products should be selected primarily for their durability and performance properties, not their cost alone. For example, compared to vinyl siding, cement board siding could be considered a more durable alternative. It will cost more upfront, but the lifespan is 30+ years. It is hail, fire, and moisture resistant and offers superior wear and tear properties with aspects such as denting and fading. Vinyl siding, on the other hand, is relatively inexpensive and offers some of the same properties, but could need replacing much sooner. Promoting products that use sustainably harvested wood reduces the environmental and social impacts of industry. Salvaged or surplus wood should be prioritized, then wood or wood products should be sourced within a third-party certification, such as the Forest Stewardship Council, Sustainable Forestry Initiative, or the Program for the Endorsement of Forest Certification. These programs ensure that industry is transparent in their environmental and social impacts, such as impacts to biodiversity and vulnerable species, emissions and pollution to land and water, and land management that affects First Nations and local communities. Light pollution is the excessive use of artificial lighting within our built environments that can negatively impact humans and ecosystems. Artificial lighting can affect our circadian rhythms and can cause migrating or hunting birds to become disoriented and end up in cities. Urban areas experience a lot of light pollution, with residents not being able to see the night sky and the stars because of lighting. The International Dark Sky Association certifies outdoor lighting fixtures that minimize glare, sky glow, light trespass, and clutter under the Fixture Seal of Approval program. The IDA has a guide to acceptable and unacceptable lighting fixtures, but it's also important to only put lights where they are needed, to direct them downwards, to only turn them on as needed, and to minimize the use of blue lighting. Blue lights can affect human and wildlife health. Using the dark sky lighting and minimizing the use of lights will also save money on utility bills due to energy saved. Indoor air quality can be a significant benefit of green homes. Let's look at how. Having entry mats, also called walkout mats, and regularly cleaning them not only keeps a home cleaner, but it also affects the indoor air quality of a house. Mats at entries will limit debris tracked into the home and reduce the exterior sources of indoor air pollution. The Worldwide Cleaning Industry Association conducted studies and determined that 5 feet of matting will remove 37% of debris from shoes, while 30 feet of matting will remove 100% of debris. 30 feet of mats is not achievable for homes, but this example illustrates that the longer the mat, the less debris that will come into the home. It doesn't have to be a permanent feature. Even temporary mats help to limit particulate matter inside the home, and they can be easily washed. Some other strategies to mitigate exterior debris include exterior walkout mats, which will reduce the dirt coming into the home, and having a shoes-off policy for occupants and visitors. Thoroughly and regularly cleaning a building helps prevent the spread of bacteria and viruses, and it helps control dust and seasonal allergy concerns. While it is important to clean and disinfect high-touch surfaces, it is also important to use products that do not contain toxic or harsh chemicals that could affect the health of occupants or the natural environment. There are many products that are safe for human exposure that will still effectively clean and sanitize. Green cleaning products can be identified by labels and certification programs. The United States Environmental Protection Agency's Safer Choice Standard and the Design for the Environment Certified Disinfectants list provide products with ingredients that are safer for humans and the environment. Additionally, there is a program called EcoLogo, which is a third-party certification program of products and services that have a reduced environmental impact. Many options are available at your local grocery or hardware store. Environmental tobacco smoke, or secondhand smoke, is harmful to humans and can cause premature death, acute respiratory infections, sudden infant death syndrome, acute coronary heart disease, lung cancer, and asthma. ETS, as a Group A carcinogen under the EPA, contains more than 7,000 substances, and 34,000 non-smokers in the United States die prematurely due to ETS every year. It is critical for the health of occupants to ensure there is a no smoking policy within the building, and there is adequate space between outdoor smoking areas and sources of ventilation such as operable windows and HVAC systems. A modern feature coming into green homes is technology. It's constantly changing, but let's have a look at two major features available today. Energy and money can be saved by adjusting the temperature during the night or when there are no occupants. A programmable thermostat is a device that automatically regulates a home's temperature based on different settings that have been specified for specific times of day. Programmable thermostats can save up to 10% of heating and cooling costs simply by turning temperatures down 8 hours a day while occupants are away from the home. Setting the thermostat 1 to 2 degrees cooler in the winter or 1 to 2 degrees warmer in the summer will minimize energy consumption and in turn save energy costs. Motion sensor light switches reduce energy consumption by addressing the possibility that lights will accidentally be left on. This, in turn, reduces the amount of electricity that's needed because the lights will automatically turn on or off only when a person walks in or out of a room. The cost and time to install motion sensors is relatively small, and the investment will likely pay itself off in just a few months. There are plenty of things that you won't find in a green home, ranging from toxic building products that contain asbestos, lead, and formaldehyde, to hazards such as radon, pests, and mold. Let's take a look at each of these examples and why they are concerns. Asbestos refers to 6 naturally occurring fibrous minerals, most commonly chrysotile. These mineral fibers are insulative and resistant to fire, heat, electricity, and chemicals, making them a convenient additive to prevent fires and chemical corrosion. Asbestos can be found in cement, floor tiles, insulation, walls, pipes, and is commonly found in buildings built before 1980. However, asbestos is extremely toxic and accumulates in the body when inhaled through the nose or mouth. Asbestos-related cancer can develop in the esophagus, larynx, lungs, heart, diaphragm, and abdomen. And as asbestosis, which is the inflammation and scarring of lung tissue, and other lung diseases can arise from exposure. Radon is a radioactive gas commonly found in rocks, water, building materials, and natural gas. It is a product of uranium in soil breaking down and cannot be seen, smelled, or tasted. Over time, radon exposure can lead to lung cancer, and radon is the second leading cause of lung cancer in Canada after tobacco smoking and causes 4,000 deaths per year in Canada. There are no symptoms of radon exposure, and because it is an odorless, tasteless gas, you may not know that you are being exposed to radon unless you test for it. Radon is found in new and old buildings, and almost 1 in 15 homes in Canada has unsafe levels of radon. It is difficult to assess exactly where radon levels may be unsafe, as homes right next to each other can have different levels. Some older buildings may have lead-based paints, and disturbing these paints by removing them, repairing them, or simply through normal wear and tear can expose you to lead poisoning. There is no safe level of lead exposure, and lead poisoning can cause anemia and brain and nervous system damage. It is probable that a home built before 1960 has lead-based paint inside, and a home built between 1960 and 1990 may contain lead-based paint on the exterior. A paint chip can be sent to a lab for analysis, or a contractor with X-ray equipment can detect lead on surfaces. Lead is a neurotoxin, and exposure in drinking water can cause high blood pressure, heart and kidney diseases, and neurological and behavioral problems. Lead cannot be absorbed through the skin, and bathing in lead-contaminated water is considered safe. Homes and buildings built before 1975 could have lead pipes in the building or in neighborhood service lines. Some municipalities have water sampling programs. It is advised by Health Canada to check with your municipality, water utility provider, or plumber to check if service lines contain lead. Mold can cause respiratory allergy symptoms and affect asthma in sensitive individuals. Eye, nose, and throat irritation, coughing, shortness of breath, and worsening of asthma symptoms can occur in people who are exposed to mold. Infants, children, elderly, and people with health problems are at more risk. And people have different sensitivities to mold. It is recommended by Health Canada to clean up all mold and control indoor dampness. Mold grows in damp conditions and can be found behind walls and in ceilings. Check for discoloration on floors, walls, window panes, ceiling tiles, and carpets, and obvious signs of leaks, condensation, or flooding. Investigate musty odors in areas with inadequate ventilation. Shower, laundry, and cooking area activities can increase building humidity, and problems may occur if exhaust fans are not being used or do not work. Mercury switches, also called silent light switches, are switches that do not make an audible clicking noise when turned on or off. They contained mercury to regulate electricity flow and prevent the clicking noise. Mercury is a highly toxic chemical that can cause severe long-term health effects to humans and the environment. General Electric and Leviton were the only manufacturers of this product, and silent light switches were discontinued in 1991, but were never recalled and are still present in old buildings today. Mercury switches can be identified by removing the cover plate and looking for the word "top" stamped on the upper end of the switch. Not that long ago, homeowners were busy disposing of incandescent light bulbs and replacing them with compact fluorescent bulbs, also called CFLs. These bright, curly bulbs cost a little more up front, but were 4 times more efficient and could last 10 times longer. But just as fast as consumers had bought into this new technology, a dark side emerged. CFLs contain small amounts of mercury, so proper disposal lands them in the hazardous waste bin at the landfill. On top of that, a broken bulb can result in a short duration of mercury exposure. Consumers were quick to phase these bulbs out of their lives and move to safer, more sustainable options. Generally, CFLs would not be found in a green home. There are plenty of critters looking to settle into a home, from carpenter ants to earwigs to mice and even raccoons. It's important to keep pests out of a home all year round to protect the health of the occupants and the strength of the structure. Some pests can carry vector-borne diseases, some pests can trigger asthma and allergies, and some pests cause microbial diseases and infections. Pests can eat away wood, compromise bat insulation, and degrade a foundation, to name a few, all of which can compromise the integrity of the building and lead to bigger problems down the road. However, a green home will eliminate many opportunities for pests because it is airtight and it has minimal moisture and has properly sealed openings and air barriers around places like chimneys and dryer vents. Thanks for joining us through this learning bite all about green and healthy homes. We hope you walk away with a set of tools to help guide you through working with these homes and with your clients. Alex is going to walk you through some recommendations on how to cover this information when you're out in the field. We'll see you in video 5.
Thanks, Ben. We've prepared some tips and tricks on how you can utilize the knowledge you've gained today when you're out working in your field. To summarize, in this Learning Bites video, we covered the following topics: what defines high performance or green homes and the range of names we use to describe them, some popular green rating systems we have available for homes, sustainable features we can add to make homes greener both during and after construction, and the benefits of these types of homes, including reduced VOCs, the elimination of toxins and hazards, and better indoor air quality. While there are many ways you can utilize this information throughout your work, here are some key pieces to remember. The terms high performance and green pertain to a wide range of homes, including both those that are and aren't certified under green rating systems. These homes operate more efficiently than built-to-code homes, but how they achieve this can differ from home to home. Ask your clients what high performance or green might mean to them. Some people value these homes for their health benefits or for the energy savings, just to name 2 scenarios. It's important to establish their personal values before presenting your clients with homes that offer these features. Remember, homes may or may not be certified to be considered high performance or green. However, certification can also increase the value of a home in some cases, which we'll cover more in video 5. And finally, prepare some information or even short information sheets you can share with your clients that highlight simple things they can do to make their homes more sustainable and healthy. This can include some of the things we covered in this video, like improving the acoustics of a space, installing low-flow toilets and fixtures, using VOC-free paint, sealants, and adhesives, installing smart thermostats, choosing Energy Star appliances, including natural products in interior spaces, and more. That's it for this video. We hope this provides you with some valuable knowledge to use out in the field as you're working. See you in video 5.